Okay, this is Algebra 1 or Spring Test Number 4 study guide. We're graphing these inequalities with two variables. Number one says y is less than 4x minus 3. It's in mx plus b form. B tells you where to begin at negative 3 on your y-axis. So this is your y-axis. You're going to go down 1, 2, 3 is where your first point's going to be. Your m value is 4. Remember, slopes are always fractions, 4 over 1. 4 tells you to go rise, which means up or down. It's positive, which means up. Run means go to the right since it's positive. So up 4 and to the right 1. So up 1, 2, 3, 4, to the right 1. There is our second point right there. If this were just an equation, we'd draw a line through those 2 points and be finished. It is an inequality, however. We have to determine, is it a solid line or a dashed line? Remember, you're looking simply at is this or equal to or not. If it says or equal to, it's a solid line. This does not say or equal to. Therefore, it will be a dashed line through those 2 points. That's the first difference with inequalities. The second difference is you're going to shade one side or the other. If it doesn't pass through 0, 0, you're going to use that point to plug it in and see if you get a true statement or not. In place of y, 0 is less than, we know that 4 times 0 or anything times 0 is 0 minus 3. 0 is less than negative 3. You're checking this statement's truth value. 0 is not less than negative 3. That's a smaller number, so you will shade away from 0, 0. Number 2 says 2x plus 8y is greater than or equal to 4. You could graph this in intercepts, or you can go ahead and move it into slope-intercept form, which most people are more comfortable doing. Move 2x over, and it leaves you with 8y is greater than or equal to negative 2x, since it came over, positive 4. Y is not all by itself yet. Divide by 8 to cancel it out and get it by itself. Do it to every term on the other side. Y is greater than or equal to. Notice we did not reverse the symbol because we divided by a positive 8. Negative 2 and 8, the number 2 goes into both. It goes into itself negative 1 time and into 8 4 times, negative 1/4 x. And then the number 4 goes into both 4 and 8. It goes into itself 1 time and into 8 2 times. Now we have an inequality that most of us are more comfortable graphing. It is in slope-intercept form, y equals mx plus b. Your b value in this case is 1/2. So when we look at our graph, we want to go halfway between 0 and 1 on your y-axis. Your slope, negative 1 over 4, tells you to go down 1 and to the right 4. So we're going to go down 1 and to the right 1, 2, 3, 4, just to make it fit. So down 1, again, will be halfway between those two. That's not a point I put. That's why I put a little dash for you. And to the right 4 times. There is your second point right there. It says greater than or equal to this time. So we're going to create ourselves a solid line, unlike number 1 through there. Hopefully straighter than that. Solid line through those 2 points. Again, it does not go through 0, 0. That's a good thing. It makes it easier for us. So we'll plug 0, 0 into both x and y. 0 is greater than or equal to anything times 0. In this case, negative 1/4 is still going to be 0 plus 1/2. So what this says is 0 is greater than or equal to 1/2. That's not a true statement. 1/2 is a positive number. Therefore, we're not going to shade towards 0, 0. We'll shade away from it. Number 3 says 3x minus 7y is less than negative 21. Again, get it into a form that you're more comfortable graphing. Move 3x over, and it'll leave you at negative 7y is less than negative 3x minus 21. Notice this negative 21 doesn't change signs because it stays on its normal side. Divide by negative 7 to get y by itself. Divide this by negative 7 and this by negative 7. That'll give you y. Negative 3 divided by negative 7, there's no number that goes into both of them, but a negative divided by negative will make it positive 3 over 7x. And then a negative 21 divided by negative 7, again, a negative divided by negative is a positive 3. We had to divide by a negative number in that case, unlike number 2 where we divided by positive 8. Therefore, we will reverse less than and make it say greater than. Y is greater than 3/7 x plus 3. Graph that by going through positive. We're going to have to make this fit 7 times over. Begin at positive 1, 2, 3 is where your first point goes because your y-intercept is 3. Your slope is 3 over 7. That means go up 3 and to the right 7. So up 1, 2, 3 more times. To the right 1, 2, 3, 4, 5, 6, 7 is where your second point goes. So up 3 and to the right 7. This is not or equal to when you look at your inequality symbol. Therefore, you're creating a dashed line to cross through both of those points, or a broken line through both of those points. And then we're going to shade based on the truth of 0, 0. When we plug it in, 0 is greater than, anything times 0 is 0, plus 3. 0 is greater than 3. Again, that's not a true statement. So towards 0, 0 is wrong. We're going to shade away from 0, 0. Number 4 and 5 are both in mx plus b form. That'll speed us up a little bit. When we graph this, we're going to go through at positive 2. That's what our b value is. So at 1, 2 is our first point. Our slope is negative 6. Remember, all slopes are fractions, so you need to put it over 1 if it's an integer form. That means go down 6 and to the right 1 time. So down 1, 2, 3, 4, 5, 6, and to the right 1 time. There is your second point there. It says greater than, not, or equal to. So through those 2 points, we're going to draw ourselves a dashed line. That tells us not to count the line in our boundary. It does not pass through 0, 0. It gets very close to it, but it'll be obvious when it passes through it. So we use 0, 0 to check the truth value of that side. 0 is greater than, negative 6 times 0. That's why we use it, because anything times 0 is 0, plus 2. 0 is greater than 2. Not a true statement. We will shade away from 0, 0. Y is greater than or equal to 2x minus 2. Again, your b value is nice and neat, and your m value is easy to see. So on your y-axis, the intercept says negative 2 as your b value. Your m value is 2. Remember, slopes are always fractions. Make them into a fraction by putting them over 1. That means go up 2 and to the right 1. So up 2 and to the right 1. Second point's going to go right there. It says greater than or equal to. Solid line through those 2. Remember, that's the determinant if it's solid or dashed. Does not pass through 0, 0. That's always a good thing. Plug in 0, 0 there and there. 0 is greater than or equal to, anything times 0 is 0 minus 2. 0 is greater than or equal to negative 2. True statement this time. 0 is the bigger number out of the 2. Shade towards 0, 0. Okay, graph both of these. It doesn't say it in the instructions, but graph both of these on number lines, especially since the first one is P. And we'll do the same thing with number 7. It says P is less than 2. So if 2 is positive, just show its relation to 0. Show it on the right side. It says less than. That means we don't color in the bubble. This is going back to 2 weeks ago. Less than, the variable is first. It's pointing that way. Shade it that way. Do the same thing with x is greater than or equal to 1. Show its relation to 0. It's positive on the right. This time, though, greater than or equal to means we do color it in or fill it in. Greater than, again, x is first, and it's shading that way. We're going to shade that direction. Or it's facing that way. We make the shading the same way. Write the following inequality in slope-intercept form. We know slope-intercept form is y equals mx plus b. The only thing that's going to be different is we won't have an equals. We'll have that inequality symbol. So you want y to be by itself. That's your goal, is to get y on the left side all by itself. So move everything that's not y to the other side. In this case, 2x is not y. It's positive 2x, which means plus 2x. Subtract it there. If you subtract it on the left, subtract it on the right. That's not going to give us negative 58x. Because those are not like terms. So we have negative 2y stays on the left, negative 2x on the right, minus 56. There is no reason to reverse the inequality symbol at that step. All you did was subtract negative 2x. So we'll leave it, say, less than or equal to. The next step says negative 2 times y. Undo times by dividing. You want to keep y, that's our goal. Divide by negative 2. Make sure to divide every term on the other side by negative 2. A negative 2 divided by negative 2 is a positive 1x. And a negative 56 divided by negative 2, a negative divided by negative is a positive. We know that 50 divided by 2 is 25, and then 6 divided by 2 is another 3. So when you put 25 and 3 together, you get a positive 28 right there. We divided by a negative number at that step, though. Divide by a negative number. That's the key that tells us to reverse our inequality sign from less than or equal to greater than or equal to. Number 9 says write an inequality for the graph. X, 4, what are we going to put in the middle of them? It says it's facing, our x is first, and it's facing this direction. So our symbol will face that direction as well. The only other thing we have to determine, do we make it say or equal to or not, based on the fact that we have an open bubble. Remember, open bubbles mean not or equal to. Had it been a colored in bubble, we would say x is less than or equal to 4, but since it's not, x is simply less than 4. Number 10, we are solving, then graphing these solutions. We're going to graph all of these on number lines, okay, not on planes. X minus 3 is less than or equal to negative 5. Undo minus 3 by adding it to both sides. X negative 5 plus 3 is going to be negative 2. All we did was added 3. There's no reason to reverse the less than or equal to symbol. When you graph that, you're going to show its relation with 0, so it's on this side. It says or equal to at negative 2, so we're going to fill the bubble in. And it says less than. Notice it's facing this direction. Our shading will go the same direction. X over 6, or x divided by 6, is greater than 10. Okay, we actually skipped number 10. Let's go back and catch number 10 real fast. It says Tina can type at least 75 words per minute, write and graph an inequality to model the situation. So we need x and we need 75. We need to determine what to put there. We know that the number is at least 75. That means it's going to be bigger than 75, or it can be 75. So the inequality we're going to put, remember, the big mouth eats the big number. X is going to be bigger in this case. 75 is her minimum. 75 words per minute. There is your inequality. X is greater than or equal to. And then it says to graph it, again, same thing. 0, 75 is a positive number, so let's put it on the right. Greater than or equal to is a colored in bubble. X is first, and it's going that direction. We're going to shade that direction. There's your graph. Number 11 says x over 6 is greater than 10. That means x divided by 6. Multiply each side by 6 to get x by itself. X 10 times 6 is 60. All we did was multiply by a positive number. Do not reverse the inequality sign. X is greater than 60. Almost the same graph as a second ago, except instead of 75, we got the number 60. And it says greater than, not, or equal to. So an open bubble, it's going that direction. Our shading will go that way. Negative x over 2 is less than or equal to negative 3. Remember, it's easier in this case, to count your -2 at the bottom. It'll save you an entire step at the end. So that says x divided by -2. Cancel that out by multiplying by -2. If you do it there, do it to the right side. -3 times -2 is +6. X is left by itself on the left. We multiply by a negative number. You have to reverse the inequality to say greater than or equal to 6. When we graph it, it's positive again, 0 and 6. It says or equal to, so we color the bubble in. It's facing that direction, so we're going to shade that way.